Hi guys, in this video we're going to be solving the operators. So firstly I'll start by doing the introduction. To the operators. So first thing first, you need to know the theorems. So there's three theorems that you need to know when you deal with the operators. And the first one is for E. So it's for AX, where AX is the f of x, or the function of x. So we're gonna start by doing one example. So for this theorem, this is A. For this theorem, you're gonna say let A equals to D. Let A equals to D. That's the first theorem. Example, if you have got E, this is example. Example 1. If you have got E to the power 2x divided by D squared plus D plus 2. If you've got an equation like this, so this equation they call it particular integral. It's a particular integral. So normally you don't find it like this. Normally you find it, so you can name this YPI. Normally you don't find it like this. You find it in the form of an equation. So you'll have D squared plus D plus 2, and then Y equals to E 2x. You find it like this. This is an equation. So in this equation, obviously you're gonna have to find the general solution. They'll ask you to find the general solution, meaning you're gonna have to find the auxiliary equation. So I can start by solving this one. If they ask you to find the general solution, so you're gonna start by doing the auxiliary equation. You're gonna start by doing the auxiliary equation means you take D squared plus D plus 2. So this equation will lead you to the particular the complementary function. So the general solution, y general, would be equals to y particular plus y CF. So YCF comes from the auxiliary equation, right? Okay, so here the first thing that you're gonna say, you're gonna take that D squared plus D plus 2, then you equate it to 0. You find the factors of that. Check if you can find the factors. Okay, check if you can find the factors. So it's 2 and 1. So it will be, we want positive 1. So it will be 2 minus 1. Is it possible to find the factors there? Is it possible to find the factors? Yes. So we need to change this. To minus. Made a mistake there. Need to change this to minus. This is a minus. So yes, it's possible to find the factors. It's a 2 and a minus 1. So you see that the factors are not the same, not similar factors. Not similar factors. So if the factors are not similar, D1 will be equals to 1, and then D2 will be equals to minus 2. Then if the factors are not the same, you use this equation, you use this formula. Y CF will be equals to C1E D1X plus C2E D2X. That's if the factors are not the same. So your YCF will be equals to C1E to the power of which one is minus to the power of x plus c2e to the power of minus 2x. See? So that's your YCF. Then we're gonna go back to the theorem now. Gonna go back to the theorem. So the theorem, let me start by writing the original equation. We're gonna go back to the theorem. So remember they asked you to find the general solution. So I always write pi on the side there, because now we are done with this part. We are done with this part. So the part that you used, you're not gonna use again. So now you have to make y the subject of the formula. So you go to the particular integral now. You're gonna say ypi will be equals to divide by that the operator equation minus 2. Then here you wanna let, because now you're using this theorem, you're using the theorem of e to the power 2x. You're using the theorem of e to the power 2x. So we're gonna say let a equals to d. So there's a difference now. For this theorem, for e, for as long as you've got e to the power ax, you're gonna let a equals to d. You're gonna replace everything. Where there's d, you put a. So the whole point of doing this equation, guys, is to get rid of d. For as long as you've got d, you need to solve the equation. So for as long as you've got d, you need to solve the equation. So ypi will be equals to e to the power 2x, e to the power 2x, e to the power 2x, and then what is our d? Our d is equals to 2. So remember, the theorem says eax. So you're going to take a only. You're going to take the coefficient of a. So you will have 2 squared plus 2 minus 2. Then this will be equals to e2x over. Then this 2 will cancel. Then we'll be left with 4. So that's your ypi. And then you're going to say your general dot solution will be equals to ypi plus ycf, which is equals to, you're going to combine the two. So your ycf is c1e x plus c2e minus 2x plus e to the power 2x over 4. So that's how you do the general solution. That's how you do the general solution for the theorem of E. So the theorem of E, the whole point of doing this question, guys, was to solve the theorem of E. So the theorem of E tells you that whenever you see D, you substitute A. Or whenever you see A, you substitute D. So that's the theorem for E. Then on the next session, I'm going to be doing the operators for sine or trigonometric function. So we're going to do the same example. The only thing that is going to change now is for this one is for trigonometric, trigonometric, trigonometric equations. So for the operators, we only have two trigonometric functions that we're gonna use. You're gonna use cos, we put ax, you see, cos ax and sine ax. It's cos ax and sine ax. It's cos ax and sine ax. So those are the two trigonometric functions that we're gonna use. So those are the two trigonometric functions that we're gonna use. Okay. So whenever you see a trigonometric function in the operators, for example, you're gonna say let d squared equals to minus, you see I'm saying minus open bracket a squared. So you're only gonna square the a, not with the minus. So that's the theorem for a trigonometric function. Whenever you see a trigonometric function, you use this theorem. Then if you have got 1 over d, means integration. If you've got d, it means differentiation. Right? So you're gonna need this in that equation. So if you see d, then let's say they gave you x squared there, then x squared there. For this one, the first one, for a, then this is your b. For a, you're gonna integrate. Whenever you have got 1 over d, remember a trigonometric function, it's a the integral function, it's an inverse of the differentiation. So whenever you see 1 over d, it means the inverse of differentiation, which is integration. 1 over d is the inverse of differentiation. So in this case, you're gonna just put x squared there, then dx, then you integrate that. So you're gonna get x cubed over 3. Then this one, if you have got d times x squared, it means you're differentiating x squared. So you're gonna have 2x as your answer. So you see, so we'll come across that when we're solving these equations. So let's go to the theorem now. So I'm gonna take the same auxiliary equation. I'm gonna take the same auxiliary equation and modify it. So I'm gonna show you two things in this equation. So I'm gonna take the one with the similar factors now. I'm gonna take the one with the similar factors. So let's put 4d plus 4. Then you put y equals to, now we're gonna say sine 3x. In this case, we're gonna say sine 3x, right? So before you choose this, make sure that you don't make any 0. We don't want 0. If you get a 0, it's a different story. I'm gonna do that on another episode or another session. So we're gonna first take out. So this question, they'll normally ask it this way. They will say find general solution using the operator method. So they want the general solution. So you see, I always say write this as ypi. Then you're gonna take this one, the auxiliary equation, you put it on the side. That's your aux equation. You don't have to write aux equation. Just take that out. So you've got d squared plus 4d plus 4. The reason I'm writing ypi is to show you that you're not gonna involve it in the equation. So you just ignore everything, you equate it to 0, then you find the factors. Find the factors. So it will be 2 and 2, positive 2 and 2 equals to 0. Do you see that these are similar factors? So I showed you the one with the different factors. Now I'm showing you the one with similar factors. So you've got similar factors here. You've got similar factors. Okay, so since you've got similar factors, you're gonna say d1 equals to d2, which is equals to minus 2. So the equation for similar factors is ycf is equals to, if you've got similar factors, you're gonna say c1e. So let me not write 2x. Let me just write d. d1 k x plus c2e d2 x. Just because the factors are similar, you're gonna say multiply by x. Just because the factors are similar, you're gonna multiply c2e2 ed2x. You're gonna multiply it with x because the factors are the same. So your ycf will be equals to c1e minus 2x plus c2e minus 2x, just multiply by x. Then that's how you do it if the factors are similar. Then now we are moving to particular integral. So remember, you have d squared plus 4d plus 4 y I always say write YPI on the side there. It's easier to remember. And then the theorem, remember the theorem for sine, it's sine AX, where D squared is equals to minus open bracket A squared. Okay, so you're gonna say YPI equals to, you divide sine 3x divided by D squared plus 4D plus 4. Okay, so now we're gonna say where there's D squared is equals to minus, what is your A? Open bracket 3 squared. So D squared will be equals to minus 9. See that? You see, it's not 9, it's a minus 9 because I put the minus outside. Don't ever do a mistake and put that minus into a squared, into a bracket basically. So we're gonna go and substitute now. You've got sine 3x divided by D squared. What is your D squared? D squared is a minus 9. You write it as it is, plus 4D plus 4. So the whole point of solving this, guys, is to get rid of D. So whenever you see D, you have to solve it further. So you have to get rid of that D. So now you're going to have sine 3x divided by, so you're going to say 4D minus, because you're going to have 4 minus 9, you're going to have minus 5. Then, since you still have D, this is what you're going to do. You're going to say multiply by 4D plus 5. So you're going to take the sign between D, 4D and minus 5, change it there. So if you had a minus, if you had a plus here you're going to say a minus. So you do the opposite. You put the opposite sign when you multiply there. You put the opposite sign between D and the other number. Let me put it that way. So you have to put it like, let's say you had 5 minus 5 plus 4D. You have to take this one, the one that is between 4D and that minus 5. So you have to take that one. So you're going to multiply by 4D plus 5 divided by 4D plus 5. Remember, this thing is like a 1. They will cancel, obviously. So you just multiply by that. So I normally put the brackets so that you can see that this numerators are multiplying and the denominators are multiplying. So you're going to multiply these two, multiply these two. So YPI will be equals to 4D sine 3x, okay, plus 5 sine 3x divided by, so obviously for this one, if you do it quickly, you're going to see that the middle terms will cancel. You're only going to have the first term and the last term. So you're going to have 16D squared plus, okay, it's going to be a minus 25. So you only multiply the first term and the last term because the middle terms will cancel. You can do it. You can expand the brackets. You're going to see the middle term will always cancel. So you're going to have 16D squared minus 25. And then you see, what is the theorem for this? You see, you are not going to be able to solve this theorem because for sine 3x or for sine or for a trigonometric functions, you don't need D, you need D squared. So that's why we did this, because you cannot solve it if it has got D. We need a D squared. So now there's your D squared, you see. And then here you're gonna solve the top one. So what did I say about this? Whenever you see this, it's like you're differentiating whatever that is in front of D. So it's 4D sine 3x. Then you're gonna differentiate sine 3x. So you're gonna have to say 4 into 3 cos 3x then plus this one 5. You cannot do anything on that one, you just leave it as it is. 5 sine 3x, then divided by what is your d? So you're gonna say 16 into, we already know that d squared is equals to 9. You see, didn't change. D squared is equals to that 9 minus 9. So you're gonna say into minus 9 minus 25. See, and then your ypi will be equals to 12 cos 3x plus 5 sine 3x divided by, so we're gonna punch this on the calculator. So you're gonna have to say, let's put this calculator right here. So we're gonna remove everything there. 16 open bracket minus 9 minus 25 is equals to minus 169 minus 169 minus 169. So you can always split them. I normally leave them like this. It's fine if you want to. I normally leave them like this. But if you want, you can just split it however you want. But I normally prefer to leave it like this because for me it's easier to work with something like this. Then remember, when you differentiate sign, you're gonna get a negative cos. So don't forget to put a negative cos there, because otherwise your answer will be wrong. When you differentiate sign, you get a negative cos. So don't forget to put a negative there. Okay, so you can split this, but I normally leave it like this. It's fine. So you're gonna combine the two. Y general solution will be equals to, what is your YCF? So YCF, what is your YCF? YCF is equals to, what is it? Okay, similar factors. So we're gonna combine YCF, which is CE, minus 2x plus C2E minus 2x. You multiply by x if they have similar factors. And then you're just gonna add. It's a minus. The first one, it's a minus cos minus 12 cos 3x divided by, all divided by minus 169, and then plus 5 sine 3x. So I normally leave it like this, but you can always split it. You can always split this if you want. And that's how you do it. That's how you solve that question. That's how you solve that question. So the next one that I'm gonna be doing is for cosh, for hyperbolic functions. So now we're gonna do hyperbolic functions. Hyperbolic functions is your cosh, ax, and sinh of ax. So that's your hyperbolic function. So you only have two. Don't take the tan. Don't take the tangent. We only use cosh and sinh. So for this one, it's similar to a trigonometric functions. Remember, for trigonometric functions, you take d squared. So we're gonna take d squared is equals to a squared. You see, the difference between these two is that whenever you've got cosh ax and sinh ax, you don't put a negative a squared. No, it's just straightforward. D squared is equals to a squared, just like that. So in this case, you're gonna have cosh 2x I don't want to mix these functions because we're gonna have problems. So I wanted to show you guys if, like, let's say for instance, we have got d squared plus 49. See this? I'm gonna just show you this one. So whenever you have got this, just know that the factors will be the same, but it will be a plus or minus. So you've got d squared. Remember, you have to take this to the other side. Then you remove the square root. So whenever you square a negative number, just know that it's a imaginary equation, or they call it root complex. They call it root complex. So you're gonna have d is equals to a plus or minus. Whenever you put a square root, it's a plus or minus 49. You see. And then you know that a square root of a minus 1 is equals to imaginary, is equals to I. So this will be equals to a plus or minus. What is the square root? So we put I there, we remove it, and then we put the I outside there. So you're going to have a square root of 49 now, a positive. To make it a positive square root of 49, I'm going to put this outside. So your D will be equals to a plus or minus 7 yes. See, if you put a square root of 49, you're going to get 7. But a square root of a negative 49, you're going to get error. See, so yes. So you see, here you've got I. You put I there, the I that is outside. So you see this. Whenever you've got a complex equation or a complex root, or a root complex, so you use this equation. Y is equals to E ax open bracket c1 cos bx plus c2 e c2 sorry sine, because the e we make it a common factor, sine bx. This is the equation that you're gonna use if you've got a root complex. The moment you've got imaginary, let me put it that way, imaginary. So in this case, normally they put it this way. They say a plus or minus bi. This is the equation, the standard equation for root complex. So in this case, we don't have a. Our a is equals to 0. Our a is equals to 0. Our a equals to 0. See there? Your a is 0 there. You don't have anything just before a plus or minus. You don't have anything. So a equals to 0, and then b. B is the one that is next to the I. What is next to I? 7. So your y will be equals to e to the power 0 c1 cos bx, which is 7x, plus c2 sine 7x, right? So your y will be equals to, so let's make it, YCF. So this is our YCF. I was just showing you how to solve it. So this will be our denominator, by the way. I was just showing you how to solve it first. Then you're gonna have anything to the power 0 is 1. So you're gonna have 1 outside. So c1 cos 7x plus c2 sine 7x. So this will be your answer for YCF. Then since we are doing hyperbolic functions, so you'll have d squared plus 49, then y equals to cos 3x. So I already solved this. I already showed you how to solve this. So you've got your YCF. Then now, remember to write YPI. So they'll ask you to find the general solution also here. And then you're going to say YPI equals to cos 3x divided by d squared plus 49. And then d squared will be equals to a squared. So where our a is equals to 3 squared. which is equals to 9, right? So your ypi will be equals to cos 3x over 9 plus 49. Cos 3x will be equals to 9 plus 9 is 18, so you'll get 58. You'll get 58. You'll get 58. So that's your ypi. And then you're gonna combine it to find the general solution, ygs. You combine the ypi and the ycf. So ycf will be equals to c1 cos 7x plus c2 sine 7x plus cos 3x divided by 58. That's your final answer. So guys, in this session I showed you how to do similar factors. Let me do a summary. So I showed you how to do similar factors. So for similar factors, it's y is equals to c1 e let me say d1 x plus c2 e d2 x. Similar factors, you just multiply by x there. Then different factors, it's y equals to different factors c1e d1x plus c2e d2x. So the difference between the one with the similar factors and different factors is that this one you put x if they are similar. It's repeating, so you put x. And then root complex or root complex, so when you've got an error. So this root complex, you normally use it when you can't find the factors. I normally use it when I can't find factors. Invalid factors. Invalid factors is a negative square root. Like you'll have a case where, like, remember, let me take you back. X is equals to minus b plus or minus the root of b squared minus 4ac. So that's why they call it root complex, root, a square root. That's why they call it root complex. And then 2a. So you'll have a case where this combination, like let's say this is from a quadratic equation, by the way. This is from ax squared plus bx plus c. This is from this equation. So there will be a case where you've got an equation that cannot be solved, where you cannot find factors, right? So you use a quadratic equation. So let's say the combination of these two, like this one was 4, then the combination of these two, it's 4 squared. This one will give you 16, for example. Will give you 16. So you'll get 16 minus, we want something bigger, so we'll say a normally it's 1, so let's just leave it as 1. Then let's get a bigger value. For example, if you put 8 there, so the equation will look like this. You'll have, let me use d squared, and then what is your b? Your b is plus 16 plus, okay, 16d plus 8. You see this? Your c is 8, your a is 1. So if you substitute those values here, do you see that you're going to get a negative root? You're going to get a negative root inside that square root. You'll have b squared. B squared is what? Sorry, it's 4, not 16. Because the reason why I got 16 is because I said 4. So it's 4 there. So That's why I got 16, because it's b squared. So you'll have 4 squared minus 4 into a. What is your a? A is 1, and then c it's 8. So do you see that this one, the combination of this will be bigger than that? So you'll get a negative square root. So here you get 16 times 16 minus 16 minus 8 times 4, get minus 16. You see, minus 16. So this is a story for another day, guys. You'll get a plus or minus root of, I'll do it some other time, 16, then you put the I outside. So that's your invalid factors. That's why I say invalid factors. So that's when you use a quadratic equation. So I'll do this on the session. So let me just leave this here so that I can work on. Otherwise, if you do have any question, guys, or you want to join our online session, please DM me. I'll leave my WhatsApp link on the description below. Please don't hesitate to ask questions. Thank you for watching.